All right, guys. So let's move. We'll be looking at resolution of more than two vectors. The last time we actually treated three cases. We had case one, where the two vectors are we have perpendicular cases where they are acting at an angle to each other, and the rest of them. That's exactly what we did. Perpendicular, acting at right angles to each other, and the rest of them. And I saw that some persons are already solving questions on that. People like Eniola, sorry, not Eniola. People like she's not here, Ferrami. Yeah, Ferrami has been solving questions on this. Justice as well, but I don't know why he's not in class. So some persons have actually been doing that, and that's a very good one. So today, let's look at how you can resolve resolution. Let's look at how we can resolve two or more vectors, right? I remember that on a good day, we shouldn't have class today, three of us. Hmm? We shouldn't have classes today, but because of how we are driven, the way we are moving so hard to see that we do well. That's why we even fix classes today that we should have rested. Um, but our major goal is to see that we do well. All right. So resolution of two or more vectors. And one key thing that we need to learn how to do is that immediately after these classes, when you watch the recording, get your past questions. Because the way I teach these things, I do it in a way that there's no question under this topic that after watching those recordings that you cannot solve. There's no particular question under them that you cannot solve. So your major goal, watch those videos, get past questions and solve them. Example, monitoring also, you are here. Have you checked your past questions on number base? Monitoring also, have you checked your past question? Okay, it's no longer here on number base. Now, because these are the persons I taught mathematics, and for any topic I teach them, when they eventually go to past questions, they will see that it is as easy as anything you can imagine, right? Because everything you need has been given to you. So now, for more than two vectors, we're going to do it in this way. Let's say we have a line this way. We'll have this one this way. This is your x, and this is your y-axis. Now, this is the vertical component, v. This is your horizontal component. Now, let's say we have a force acting this way. Remember that vectors can be is a quantity that has what magnitude and what direction, right? Magnitude and also has what direction. It can be acceleration, it can be velocity, but for now we're making use of force. So let's assume that the force I have here is F, right? Which is the vector we are considering to get today. So the vector we're looking at today is we're using forces as an example. So and there's an angle between this very resultant vector, this is your F now, to the horizontal. There's an angle here. So let's call this angle theta, the angle between that force and the horizontal line. Now, you are asked to find the resultant component or the horizontal component of this force along the y-axis, and the horizontal and the vertical component, vertical component of this force along y-axis, and the horizontal component of this force along x-axis. Remember that H represents your horizontal, right? You are trying to resolve two or more vectors, but then it's about you resolving this in the y-axis and along the what? The x-axis. That is exactly what you are asked to do. Now, pay attention to this. That from here, I have, if you are following, can you give me a thumbs up? Let me be sure that I'm not talking to myself as it stands. Yeah, a thumbs up to know that I'm not alone, guys. Good. Thank you, confidence. Thank you, Titiola. Hosanna the man. Hold on, bro. All right. So, Mesoma, thank you. Hosanna, you too laugh. You like laughing, my bro. I think if we have people like you in this planet Earth, plenty of you will not have any problem. All right. So you have that very angle there, and now the horizontal vertical component of this force along this line, right, is going to be what we'll call it our Fy. Now we can as well complete this. Please pay attention. We can complete this. Sorry. You can complete this line. Let's form a triangle from here. Let's just form a triangle from here. Let's just form a triangle. Let's just form a triangle. And then let me extend this line of force. Good. So the vertical component of this force is what we call our Fy. While the horizontal component is what we call our Fx. Now, if you look properly, you will see that we have a triangle here. We'll just form the triangle. We'll form the right angle triangle. That's exactly what happened here. We did what? We formed the what? A right angle triangle. And now with this right angle triangle, everything navigates around here. Remember, what are we doing? We are trying to learn how to what? Resolve vectors in the horizontal and the vertical direction, right? For one or two or more vectors. Now, we could form two what here? We could form a right angle triangle if you observe properly. Now, look at that right angle triangle. I can bring out a right angle triangle from here. Remember that this place is also equal to this place. So I've not made any mistake if I also call here my Fy, right? Because they are what? They are equal. So that place as well can be my Xy. But now it doesn't stop here. I want to resolve in the vertical and the horizontal direction. So what am I expected to do? Now, remember that I have a triangle. That triangle will look like this, a right angle triangle, this way. I have this one. So let me just take it closer to the side so we can have more space. Let me make it a little bit bigger. Then let's have it right here. So there's an angle right here. This is my theta. Remember that I have my Fx here. I have my Fy here. And I have the force F in my horizontal. Remember, this is your right angle triangle. And here is your 90 degrees, as always, like I explained the last time. All right. So that said, we also have that here is also a 90 degrees. Beautiful. Now, let's go ahead. Now, I want to make use of our knowledge of what we call SOHCAHTOA. How many of us can still remember our SOHCAHTOA? It's something that we learned right from junior secondary school. So, and tour. Right? You can still remember this. That's why you're laughing. What's funny is it the SOHCAHTOA? All right, so it's something we learned back then. So now with this, remember that in a right angle triangle, and I want to believe that each and every one of us know the side that is the horizontal and the side that is the vertical, right? Let's paste it right here. So I want to label my opposites and my horizontal there for ease. So we'll have here, clean up here. This is your hypotenuse. This is your opposites. And this is your adjacent. Now, when I'm trying to get the vertical, the horizontal, what do you call it? The horizontal component f of x, right? The force acting in the horizontal direction. What am I going to use? Let's see what will happen if I'm looking for what? F of x. So I'm going to make use of the sin theta and the cos theta. This is for sine, this is for cos. So let's start with sin theta and see the variables I can get with that. Now, making use of your sine, it means that sin theta is equal to what? Opposite. What's my opposite here? My opposite is what? Fy. So opposite is what? Fy all over. So this would be F subscript Y so that it makes sense for people that have done Gary so much. So this is our Fy divided by f of x, right? So we have opposite of our what? Hypotenuse. So your opposite is what? F of y. Then your hypotenuse is what? Is f. So that means that I have what? The value f right here. Therefore, f of y, if you cross multiply, you have that f of y is what? F sine what? F sine theta. Mary keeps leaving the meeting. Mary, are you using 2G network? Fg, F sine theta. So if you're looking for the what? The horizontal component, right? I keep saying horizontal. If you're looking for this force here, the component of the force in the vertical direction, that is when you have a force at an angle, right? If you have a force at an angle and you are looking for what? The vertical component of that very force, it will give us what? Fx what? F sine what? Sine theta. So resolving this particular force to the what? To the vertical. So what am I trying to say? Look at this. Observe this. I wish my camera is on, but then I came back very late. I couldn't set up. So look at this. When you hear about vertical component, this guy is this way. Look at this. This force is pointing this way. So you kind of you want to push this guy to become a straight line. Like you want to bring it to the y direction, right? I don't know how else I'm going to explain this so that it will make more sense. More like you have a line like this. Just use this. A line is slanted like this. This line is slanted this way. Now, and there's a line this way. There's an angle here. But then you want to bring this guy to align to this place. So it can become a straight line. You want this guy now, not just to slant, but to come and align here. You want it to align on top of this. So for it to align here, and there's an angle here, what you are going to do, let's say that the force here is F. You want to get the vertical component of that force so you can actually align here. You are not going to do what? F sine theta. So that's the vertical component of this force, which we call Fy. If you understand what I'm saying, can you give me a thumbs up at all? Like if you get the concept of what I just said in terms of pushing that force to the other side, give me a thumbs up. Yeah. Titola, I don't understand it. Titola, I don't understand. Titola, I don't understand. Someone gives a thumbs down now. I don't understand. Okay. Now, I need to turn my video to actually explain this. Okay, let me try. Let me try. Just give me 2 minutes. Because if you don't understand this, this is the foundation of everything. And if you don't get it, then there'll be a big problem. Because everything revolves around the ability to resolve your objectives. Now, for the sake of our sister Titola that you understand, let's find our way around it. So that she too will understand. Hope we are good with taking our others along, right? I think that's our rule. We need to take others along. All right. See my face the way I am. Just manage me, right? Manage me the way I am this morning. But this video is recorded. That's my problem. So, but then it's fine. I was rushing to meet up. So look at my hand, right, Titola? I will hold you responsible for catching me off guard this way. Now you have a line like this. Look at my hand. Can you hear me? This is a line like this, right? And the force is this way. Look at how the force is. But you don't want this force to remain like this. Can you see my hand at all? Good. You don't want this force to remain this way. You want the force to stand straight. That's the vertical direction. The force was like this, but we don't want it to stay this way. We want that force to go to the vertical direction this way. So you are trying to push it from the slanted mode. Remember that there's an angle here. It was like this, and there was an angle here. Or there is an angle. English. Anyone, was, is. Take one. If is correct, take it. If was is correct, take it. So there's an angle here, and you want there's an angle here, and you want this guy not to be slanted again. You want that guy to go up this way. Do you understand the fact now? So what will you do? To push it this way up, you are resolving to the vertical direction. And that vertical direction is what we call Fy. F subscript y. That means the vertical component of the force, F. And that force was slanted before. A slanted force, and we are pushing that force to become a straight line to the vertical. So to resolve that, that's what we just calculated. That will give us what? Fy sine theta. Sorry, F sine theta. So pushing that force to the vertical. Does it make sense now? If it doesn't make sense after this, the way you did me on to turn my video on, it doesn't make sense, Tiola. Are you sure? All right, beautiful. Thank you. And for the punishment you gave me, I'm not happy with you. For letting these guys catch me, they just caught me off guard like this. Now, the next one I want to talk about. If I now want to resolve, let's now resolve this guy to the horizontal. Remember that it is still slanted this way. The force is still slanted this way, and I want to resolve to the horizontal. How will I resolve? I'm going to bring it down like this so that it becomes horizontal. So that force horizontal is what we call the Fx, the horizontal component of the force. This side, bringing it up, the vertical component of the force. Remember that it is slanted. Anytime it is inclined at an angle, what you want to do is to push the force up, vertical, or push it down, horizontal, so that it lies on the X and the Y plane. I believe that everybody understands it right away now. Three of us. It makes more sense now, right? I know. So everybody should thank Tiola. I think that picture I showed now made sync better, right? It made it make more sense. Yeah. So you guys should thank Titiola. Good. Thank her for actually pushing for me to do that. Good. So you are just resolving. So if I start drawing something like this guy is slanted this way, I want to push it up. Let everybody put their hand and we push it up so that it can stand straight. So that standing straight is what you are trying to get here by making this guy your vertical component. Now, the force is inclined at an angle. I don't want it to stay this way. I want to get the horizontal component. I will push it what? I will push from here. I will bring it down. I'll push it down. Beam to this point. I'm asking drama. Which one is beam again? So you're going to have an arrow pointed to this side. Do you understand? So that will give you what? Your horizontal component. Yeah. So that's how we are trying to do. Well, that's exactly what we are trying to do. We're just trying to resolve the forces. So the Fy component, by bringing it up, mess up. You laugh a lot, you and Hosanna. But that's a good one. I like people that laugh. All right, so that's your Fy component. Now, the next one again, my people, right? Now, let's turn. So I want to resolve. Now, we've done for sine theta. Let's do cos theta now because I want to find my horizontal component. So remember, this is your vertical component of the force when the force is inclined at an angle, right? Vertical component when it's inclined at an angle. And this is your what? Horizontal component. Sorry, vertical component inclined at an angle. So let's go ahead and find the next one, which is your what? Your horizontal component. So let's check. Cos theta will be equal to what? Adjacent over hypotenuse. Adjacent is fx, right? Adjacent is fx all over what? All over hypotenuse, which is f right here. So when I resolve that force, I'm going to have that fx is equal to f cos, sorry. Fx is equal to what? F cos theta. Do you see the magic there, right? So what I will do to get the vertical component of this force inclined at an angle is F sine theta. And what I will do to get this horizontal component is what? F cos theta. Does it make sense? So remember that this is our what? This is the horizontal component. These are horizontal components. The other one is a vertical component. So we have our horizontal. We have our, what do you call it? This is the vertical component. And this is horizontal component. Now that we have a full class, remember I said something that this weekend, or even today evening, you are going to be seeing us removing some persons from the group chat, people that are not serious. And that's to tell you that we have an opening. And some of you reached out that there are friends you have that you want them to join. So that person should send me a direct message. Any person you want to that will replace those people who are taking off, send me a direct message on WhatsApp. We interview that person to ensure that that person is serious. So now this is the horizontal component of the force. Now, but I don't want you to think that at every point in time, it is always Fy. If you're looking for vertical component, you do F sine theta. If you're looking for horizontal component, you do F cos theta. No, it doesn't work that way. Now, let's consider another case now. Remember that for this time around, observe something, that angle was with the horizontal direction. The angle was with the horizontal. If you get what I just said, give me a thumbs up. The angle was actually with the what? The horizontal. Makes sense. Thank you, Hosanna the man. Yeah. Titola. No, so thank you. The angle was actually with what? The horizontal. Thank you, Meso. Thank you, Anna. Yeah, beautiful. So now, that said, what happens in a case where the angle is with what? The vertical, right? So we treated the case one, angle is with the what? Horizontal. Now, let's look at case two, though I didn't mention case one and case two in the previous one. So, but let's look at the second case. Now, imagine something. Please, because of how lazy I am, permit me to just copy this diagram. But you guys know I'm not lazy, right? You know I'm not lazy, actually. I'm not. Stella, thank you. Stella, no, I'm not lazy. Meanwhile, Stella, you know I called you by 4:30 today, but it was as though someone else was answering that call. Even confidence. All these 4 a.m. challenge people. The way they answer me with sleep eyes, oh, confidence was active. Oh, thank God for you. Yeah, if you want to join that challenge, we are open. We woke up around 4 and then we read till depend on our schedule, right? Yeah, I hope it has been helping you guys. Yeah, 4 a.m. wake up challenge. 4 a.m. wake up challenge. Wake up around 4 a.m. That's what we do. So if you want to be part of us, we have a group chat for that as well, for people that want to wake up by 4 to read, right? So I usually call them by 4:30 so I can give them chance for those of them that will be rotating on the bed around that particular time. But the good thing is that, you send me a WhatsApp message. The good thing is that once you do that for 21 days, it becomes part of you. So let's consider a case where the angle is now with the vertical. The angle is now with the vertical. Do you see what happened here? Now, you are going to form an angle. Remember that I know some persons will be confused, but the law will grant you understanding. Do you believe that here also is theta? Do you agree? If I call here, let's call here A. Here is B. Do you believe that A is equal to B? Yeah, who will tell me the reason? You learned that in your primary school, primary 4 to be precise. So what's the reason behind that?
I think it's something about adjacent angles are equal.
Is it adjacent?
I can't
Alternate
remember.
angles better. Alternate,
Yeah,
yeah, alternate. But
yeah.
I'm glad that you know it already, yeah. So alternate angles. Yeah, Emmanuel, that your spelling of alternate is very powerful. So now, the next thing I'm going to do, I'm going to bring out that very triangle. So I'm going to bring out, Hosanna, you laugh a lot. I'm going to bring out this very triangle. Any small thing on the group that you're laughing, in class you're laughing. We're going to bring out this very right angle triangle. Well, that's a good one, like I said. So let's bring out the right angle triangle. We have this. We'll have this. Then we'll have this. So the angle at this point here, I called it what? B. Remember that we have our f of x here. We have our f, which is that angle that was slanted. We have our f of y here. Also, we are going to be applying our SOHCAHTOA. Are we together, guys? My people, if you are still with me, can I get a thumbs up, guys? All right, thank you, Nonso. Thank you. Susan Abraham just joined. You will soon drop voice note for me again to give me 1,000 reasons why you couldn't join. Fine. I know all of you. All right, so let's proceed. So the first thing I'm going to do, let's check sin theta to see what sin theta will give us. Let's check what sin theta to see what sin theta will give us. Now, what will sin theta give us at this point? Let's check and see what sin theta is going to give us. Now, for sin theta, guys, we have sin A. Is that not so? Sorry, sin B rather. We have that sin B is equal to, what is our opposite? Our opposite is what? Remember, the side have changed. Here is now our opposite. The side facing this very angle is our, let me put my 90 degrees. If you agree with what I said, give me a thumbs up. That this side is now our opposite. That side facing the angle. This is our opposite now. This is our hypotenuse, and this is our adjacent, right? If you don't know this, please, if your younger sister that is in primary 4, when she comes back to school, just tell her to help you. So now you have sin B. That is something you want her to show, just a little thing to show you. Just ask it in a very smart way so that she will not know. So you have sin B. Then the opposite here is what? Fx. All over hypotenuse here is f, right? So now when we cross multiply, because we are looking for fx, when I cross multiply, sorry, I don't know why it is scrolling so hard this way. So I'm looking for fx. So in that case, we're going to have that our fx will be equal to what? F sin b. Do you notice what happened here? So this is the vertical, this is the what? Horizontal component of the force, right? When the angle is with what? The vertical. The angle at this point is with what? The vertical, and not with the what? Horizontal. So in any case that happens, take note of what? The change. Now, let's go ahead and look for what? For cos theta and see what happens for cos theta. So for cos theta, we can write that sine. Are we there, guys? We can have that sine, not sine again, please. We can have that cos B is equal to, our adjacent is what? Fy is equal to adjacent Fy all over what? Hypotenuse, which is f. Now, when I make my f subscript y the subject of the formula, I should have that f is what? F cos b. So f multiplied by cos b. So this as well will give you what? The vertical component when the angle is with the what? With the horizontal. Does it make sense, guys? So when I'm with what? The vertical, the answer should change a bit. So with the vertical, we have a different thing altogether. Then when the angle is with the horizontal, we have a different thing altogether. So your goal is to check, where is the angle? Is the angle with the horizontal, or is it with what? The vertical. So that's the only question you are expected to ask yourself. If the angle is with the what? With the vertical, that means that you have F sine B to get the what? Horizontal component. Does it make sense now? Does it make sense? Right? So let's scroll up again. We'll have two cases. Case one, when the angle is what? With the vertical. You can see that the angle right here is actually with what? The vertical. This is, sorry, the horizontal. This is where the angle is. Then we'll form the triangle. We'll have F sine theta. That is for the vertical component, right? F sine theta for vertical components, and F cos theta for horizontal components. But when you now flip it, there's a different case altogether. So in summary, we'll have two cases. In summary, we have two cases. Case one, angle with the horizontal. Angle with the horizontal. So when we have angle with the horizontal, what happens in that case of angle with the horizontal? So what happens? Let's quickly get that diagram, right? Because I have so much energy to draw. I paste it right here. Then this is our case one. So permit me to delete this y I wrote here, this I wrote here, and then this very angle here. So in that case, we formed two angles. We said that for that very case that we have right here, that for our vertical direction, so I have the first one is the, let me do the horizontal. So horizontal component, we have fx is going to be equal to what? F cos theta, right? We're going to have F cos theta. Did you see that? Then the next one is the vertical component when the angle is with the horizontal. The vertical component, Fy, is equal to F sine theta. So we have the second case, which we tag our case two. So our case two, let's copy here. I don't know, the way I'm taking this exam serious, you think it looks as though I'm even more serious than those writing the exam. The way it is giving me sleepless nights, it looks as though I'm serious. I'm telling you the gospel truth. The way it's giving me sleepless nights, it now looks as though I'm even more serious than those writing the exam. So when the angle is with the vertical, I'm not saying that to exaggerate. I'm telling you what it is. So when the angle is with the horizontal, with the vertical, I have a theta here. So that means here is also what? Theta as well. So the angle is with what? The horizontal, the vertical, I mean to say. So in that case, we'll have that the horizontal component. The horizontal component, f of x, at this point will be equal to f sine theta. Are you seeing the changes there when the angle is with the vertical? And then we'll now have the vertical component will now be equal to what? Vertical component is going to be Fy, right? Going to be Fy, which is equal to F cos theta. All right, so that said, I think I've given us the key things that we need for our case one, case two, and case three. So he that has ear, let him hear. But I know that some of you don't get ear. But by fire, by force, you will have ear. So this is case one, case two rather. This is case two. And then this is case one. Yeah, I wrote it there already. So any questions so far? Any questions so far? If we are good, give me a thumbs up. Everybody, if we are good, give me a thumbs up. Good, good, good. Now, it doesn't end here. There is something else that we need to know. So case one, for people that want to write, I know that most of you are not writing. So this is your case one here, like I did. So I have Fy cos theta, right? So we'll have your case two, just that way. So that said, let's look at another condition. Now you have we have four quadrants actually. right? We have 4 quadrants. We have something like this. So here is your y, just like your graph. In your graph now, I go again. Nobody's talking. So let me respect myself and start from beginning. So just like your graph, you have a line like this. Let's plot our graph. Just like in your graph, you have a line like this for your graph. Now, in graph, remember that here is your positive y-axis. Is that not so? This is your negative y-axis. I know some of you didn't plot graph back in secondary school. Don't worry. So here is positive x-axis. You copied graph. I know some persons copied graph in secondary school. But now I'm teaching you how to plot graph, should in case you copied. So now I have plus x. Then this side is your minus x. Does it make sense now? So you have 4 cardinal points. So what am I trying to say? If that force is within, this is the first chord, chord 1. This is your second chord, chord 2. Sorry, what happened? This is your second chord, the second quadrant. This is the third quadrant. And here is your fourth quadrant. So in every case here, if you have the force going towards the fourth quadrant, if the force is in the fourth quadrant, right? Let's say we have an angle right here. What am I trying to say, my people? That for that very first quadrant, that every force here, if you resolve it to the positive, to the vertical component, is going to be positive. If I resolve it to the horizontal component, the force is going to be positive. Now, if I have a force towards this direction, if you don't understand, ask questions now. If you miss it here, you're on your own. Now, let's have another force pointed to this direction. If the force, this force now is inclined at an angle, if I want to resolve it to the horizontal, that force is going to be positive. If I resolve to the vertical, it's going to be negative. So for example, let's say we have an angle right here. Let's say the angle is here. I'm just trying to bring up angles. So don't ask me so much questions. So I'm just forming angles. Let's say we have an angle here, and the angle I have here is theta 1, right? Let's say I have another angle here, theta 2. And let's say that the force I have here is F1. Let's say I have a force of F1 right here. And the force I have here, let's call this one F2. So what I'm trying to say is that if I resolve this force to the vertical, you know it's going to be what? It's going to be what? F1 what? Cos theta 1. Because it's in the positive direction. Then if I resolve to the negative, to the vertical side, it's going to be what? F1 sine theta 1. Because the angle is with the horizontal. Now, if I want to resolve this very force that is towards the second quadrant, if I want to resolve it to the horizontal, it's going to be what? F2 cos theta 2, because that angle is with the horizontal and is towards the positive direction. I'm taking it. Now, if I want to resolve this F2 to the y component, I want to straighten up to the straight line here. Because here is the negative side, I'm going to have minus F2 sine theta 2, because that angle is here. So the same thing applicable to this side of the equation. I'm getting confused. Don't worry. The confusion just started. But just calm down. You're going to understand it. Is that okay? Just one step at a time. So we have an angle tweeted to this side of the angle. This side we have an angle right here. Now, what I'm trying to say, just like when you plotted your graph, in plotting of graph, that's the same thing we're doing here. Now, the force here is going to be a negative force. Look at what I'm saying, young people. So I have, as I'm saying young people, as if I'm old. So now we have F3 here. Now, take this F3. This F3 is in the third quadrant. So it's going to be what? The value of F here, even if they gave me 40, it means minus 40 because of the virtue of the position where the force is. Now, if I want to take it to the x direction, by the virtue of the position of this force, if I take it to the x direction, it's going to be negative as well. Now, let's say I have another one. When we solve a particular question, you understand what I'm saying. Now, I have another force right here. You might not understand now, but when we solve a particular question, you will understand. So don't worry if you don't understand what I'm saying now. But just open your ear. Just be hearing that thing I'm saying. Just be hearing it. Let it make like a sound to your ears. So let's have F4 right here. it is on the negative x and positive. So if you come to the horizontal, it's going to be -4 cos whatever sin or sine anything. But on the positive, on to the vertical side, it's going to be what? +4 fy. If you understand what I said, let me see those that understood. Give me a thumbs up. Hosanna, thumbs down. Okay. Anyone that understood what I said? Confidence, thumbs down. Ferrami, thumbs up. Titola, thumbs down. I think a good number of students, you understand what I said. Okay, now let's solve an example. But then, assume that you didn't see anything like this today. What did I say? Assume that you didn't see something like this today. Just remember this one for me. Before I will give this one, you will not forget what I said here. But do you understand the case 1 and case 2 I gave you guys? Do you understand the case 1 and do you understand the case 2? Good. You understand case 1 and case 2. Okay, beautiful. So if you understand case 1 and case 2, don't worry. Okay, Meso, ask your question. Yeah, Meso, ask your question.
Okay. So like if the angle is going towards the vertical, it will be positive, and if it's going
No,
towards the
not the angle per se. Not the angle. I mean the value of the force. Look at what I'm saying, eh? Now remember, okay, my people, when you have a graph, let me erase all of these things I wrote now.
Okay.
Let me erase these angles now. Let me just ask a simple question. My people. Let's erase this. Now, if you have a value here, let's say we're counting in 2. What will be the, let's say we're counting 2, 4, 6, 8, 10. I'm counting 2, 4, 6, 8, 10. When I want to write these values on the y-axis, what will I write on this side of the graph? What will I write here? One person can answer. What will I write on this part of the graph? If I'm counting in 2, 4, 6, 8, 10, what are the values I'm expected to write this side of the graph?
There will be negative.
Negative, right? So I'm going to have, good. I'm going to have -2, right? -4, right? -6. Is that not so?
Yeah.
Now, but if I come to this side of the graph, will I still have negative?
No.
No, I will not have what? 2, right?
But,
I will have
yes.
4, right? Good. I will have 6, and I'll have what? 8. Makes sense. Now, let's also say I want to count in 2s on the right-hand side of the graph for x-axis. I will still have positive. Is that not so? So I'll have positive what? 2, positive what? 4, positive 6, positive 8, just that way. But when I come to the left-hand side of the graph, will this be positive for x-axis?
No.
No, it will not be what? Negative what? -2, -4, -5, -6. So what am I trying to say? That in terms of forces, let's now bring in forces. If we're now working with forces and a force is projected to this side of the graph, let's say that the value of that force is 15 Newton. If I want to resolve this 15 Newton to the positive, to the vertical direction, this side now, to the positive, this, look at where the place where this graph is, that force is. The force is where? On the positive x side and the positive y side. Which means that this value of 50 is positive all through. Whether I'm taking it to the vertical, or I'm taking it to the horizontal. Now, but if this same 50 now comes to this part of the quadrant, I hope it will make more sense now, comes to this part of the quadrant, let's say that same 50 now is no longer that side. The same 50, but at this point in time, the 50 is there. If I'm making reference to this 50, taking it to the x-axis, because of the fact that this 50 guy is at this part of the graph, if I take it to this side, it means I'm working with +50 in terms of x direction. But if I'm taking it to the vertical, it is now what? -50. By the virtue of the place where the force is, the quadrant where the force is. Does it make sense now?
Yes.
Every other person, does it make sense? Thumbs up if it makes sense. Every other person. So thank you. Mesoma, thank you. Titola, what's up? Good. Who again said no earlier? Confidence, are you here? Confidential confidence. Okay. If you don't carry bearing, come again. Leave bearing first. Just understand positive, negative. Now, I know it is bearing. Just positive, negative. You're going to bearing. Very soon you take me to standard form. So now, do you get what I'm saying now, Hosanna? Leave bearing for now, Baba. Just stay where I left you. I'm still within this place. You're going to bearing. All right, so we are all on the same page now, right? Regarding the position determines where it is. So now having said that, let's take an example. So the direction where the force is determines where the force is going to go. So we'll have positive and we'll have negative. So let's solve a particular question and let's get our hands dirty, guys. If you are ready, give me a love emoji. Because it's only on this class I receive love emoji. Love emoji. Let me manage it now. So after the class, I will not see love emoji again. So this is only the class I receive love emoji. So that's why I always request for it. Because I know after now, no more. So let me enjoy it while it lasts, Because I know this one will sweet you. I know you will laugh. Don't worry, I'm working on it. Very soon I'll invite you guys. But for now, let's pass our exams for now. That's the most important. All right, guys. So consider this force. They say we should find the resultant force. And there are two of them. Can you see my screen? Free food loading. It might be a course and I might decide to do anyway. So we'll find the resultant. So I will save money. Good. So we'll find it might be a course and I'll decide to do. You never can tell, Never can tell. All right. So that's for that. So let's resolve. So look at where those forces are. They gave us 30 degrees here. Can you hear that sound? Back in the days. So now we'll have 30. We'll have 30 degrees here. I'll have 45 degrees right here. Now, there's something we call special angles. I want to actually bring in the images of special angles so that you take note of those special angles because I'll be making use of them as the case might be at this point. So let's bring in our special angles. Let's bring this in, special angles. We're going to be using them for our calculations today. Good. So if you see that, look at the special angles. You will actually see, if you have eyes, and those eyes can see, you will observe that sine 0 is 0, right? Sine 30 is 1 over 2. Sine 45 is root 2 over 2. Sine 60, root 3 over 2. Sine 90 is 1. So this is what we call the special angles. And this is what JAMB expects you to know before coming to the exam hall, right? So you don't keep asking your neighbor and they send you out of the exam hall. And then the ladies will shed tears while the guys will form as men. All right, so let's resolve accordingly. So the first one is we'll have F1. And you can see that the angle is with the horizontal. Can you see that, guys? The angle is with what? The horizontal. But should in case you forgot the case that we have here, just go ahead and put a line here. Form a right angle triangle here. When you form a right angle triangle here, you put here to be your fx. Are you together now? And put this side to be your fy. Then you apply your SOHCAHTOA. Should in case you forget by any means, right? But at this stage, I don't need to be doing this sin theta cos theta, which if you solve more questions as well, you don't need to be what? Checking it. But should in case you forget, just know that this line here is still the same line here. This is your y-axis. This is your y component. This is the x-axis. Then you can apply your SOHCAHTOA to resolve it. Now, since the angle is with the horizontal, we know that our fy, let's handle all the horizontal components. The horizontal component. Because remember, we're looking for the resultants. Find the resultants for what? When there are plenty of them. So the first step now, I have my F1. So let's resolve F1 to the what? The horizontal, which means look at the line here. So I want to drag this line down. I want to do what? I want to drag that line what? Down, right? To the y-axis. So thank God for that very illustration I gave in the beginning of the video. And I'm very happy that Titiola was insisted that we actually showed that, which is a very big plus to her, right? If not, a lot of persons becoming big boys, why they're actually so confused, right? Yeah. All right. I do that a lot back in school. You have a particular question, but then you don't know how to ask it, and you just be praying in your mind. Let someone else ask that question. And when the person asks the question, you'll be like, oh God, thank you. So that's exactly what happened in our class this morning. So let's resolve this guy. First of all, horizontal component of F1. horizontal component of F1. So let's resolve this guy. Let's bring it down to the horizontal component. So that force is F1. And remember that here is our plus Y. Is that not so? Here is our plus. This is our negative. This is our positive X, negative Y, then negative X. Do you remember that our rule? Negative, positive for the quadrants. So horizontal component, I'm going to have that the Fx here, right, will be equal to what? F1 cos 30, right? So that the horizontal component will now be equal to what? 200 cos 30. And now, based on our special angles, you are going to see that cos 30 is root 3 over 2, right? Root 3 over 2 is our cos 30. So I'm going to plug in my value for that very guy. So let's go ahead. It means that I have that fx is equal to 200 times by root 3 over 2. Now, for some of you that can divide very well, you know that 2 can cancel out here to give us 100. So that f of x for the vertical component, for that guy, we have that fx here is equal to what? 100 root 3. So we're going to keep that our horizontal component of the force for that our F1. So let's keep it intact, right? And remember that this F1 here, it is positive because of what? The force is on the positive x-axis, right? So we've resolved this F1. Now the next job we need to do is to resolve this F2, right? We're going to resolve F2 because we have two forces here. Remember, we're looking for the resultant of two or more vectors, as the case may be. Sometimes it might be up to 6. If you take your physics textbook, you should have up to 6 of them, and they want you to resolve that. I wish you all the best. But once you understand the steps, you could do that. So F2 here is 300, and the angle is 45, and that angle is with the horizontal. But remember, I want to push this very F2 down to the horizontal. I want to push it down, right? Push here. Sorry, people, I can't hear Igbo. So push it so that it aligns on this very side of the line. Titola, I wish I can speak push in push it down in Yoruba. I've been trying to learn Yoruba as well. I don't know what to say. So push it down to this line. So it actually aligns on this very particular place. But remember that this part of the force for the horizontal component is on the negative axis. Have you seen what I was talking about? It's on the negative x-axis, right? Because the symbol here is negative, just like the graph I taught you about. Anyone can go. Okay. So now let's go. So it means that because you are Igbo, that's why I say anyone can go. If I'm speaking this thing now, will you be happy? So let's call this one fx1. Let's call it x1. So the second one now, let's call it fx2. Do you understand? So that we can have a context to that. All right. So the next one, I have the next fx2. So I don't mind them, eh? Different meaning exactly. Tell I'm sorry for speaking Igbo. It's not accepted. No, those that I gave, I couldn't hold it back anyway. It just left my mouth anyway. Forgive me. Next class I will say Beni, Bele. Everybody's lost now. Thank you. Adube. I know the Igbo guys are surprised. Stay there now. I'm very brutal. So now we have F2 right here, which is 300, and is on the negative axis. Be laughing now. She knows I'm correct in what I spoke. So 300, this is negative right here. So I'm going to have, and it's acting with the horizontal. So I'm going to have negative, I have negative 300, right? Negative 300 cos 45. So that's fx2 is equal to what? Negative 300 cos 45. Let's get the special angles. So special angles cos 45 is root 2 over 2. Can you see that? Root 2 over 2 for the special angles. So I'm going to plug that right into the equations. So that will be what? Times by root 2 all over 2. For people that can divide very well, you could actually see that we can divide something right here. 2 can cancel 300. So that we'll have that fx2 is equal to minus 150 root 2, right? So we can take note of that. Good. So we are done with our horizontal component of the force. We've resolved all the forces they gave us to the horizontal direction. So now the next work we're going to do now is your what? Your vertical direction, right? So we can bring them together. Total fx will be what? Fx1 plus fx2. Are we together, guys? So that fx, all the forces in the horizontal direction, is going to be what? The first one is what? 100 root 3. So we have 100 root 3 minus 150 root 2. Are we there now? But we know we cannot subtract this the way it is. But you can use your calculator to see whether you're going to get a particular value, right? Yeah, this is not a JAM question. For JAM, they will give you something that will simplify to give you a value. They want you to apply the knowledge of your sort, right? I'm just using the special angles because they might not, you might not have angles that are going to point with your calculator. All right, so that said, let me quickly solve that for the vertical components, guys. So let's look at vertical component. If you understand all the horizontal components, can you give me a thumbs up? We're looking for the resultant vector. So you're going to get all the horizontal components, add them together, then you move over to your vertical component. If you understood it, okay, good. Well done. Now, sorry guys, I stepped out a bit to get something that will power up the phone. All right, so let's continue. Yeah, so let's move to the vertical components. All right, vertical component. I was thinking that by before I will return that people have done the vertical component. But everybody is just seated waiting for me. All right. So for vertical components, let's consider what we have. The angle is with the horizontal, right? So this time around, we are pushing it up to the what? To the vertical, but that angle is with the horizontal. So it's going to be what? F1 what? Sine 30. Remember that this angle is towards the first quadrant and y is positive at that point, right? You can see that that angle is here, 30. So I'm pushing it towards the what? The x, the y-axis, and that side is positive. So what that implies is that I'm going to have the vertical component of the force, right, is going to be, let's call it Fy1, will be equal to, the value of the force there is 200. So 200 sine 30. At least I forget, let's sum up this, our total here. We'll have a value for Fx. So now Fy1, the vertical component, the sine 30 should be 0.5, 1 over 2. So that is 200 times by 1 over 2. So that Fy1 will be equal to 100 Newton. So I forgot to put the Newton on all of these things. So am I solving mangoes? So I should put Newton. So remember to put Newtons in all of them. Now let's go again. So we have our Fy1. Good. Now the second one, vertical component of the second force. Now remember that this particular force is still on the positive y-axis. So I want to drag it from the way it is here. I want to push it up to stand up straight on this line. I want to resolve it to the vertical direction. And now by the sine, the angle is with the horizontal, 45 degrees. So I'm going to have cos right here. So I'm going to have sine again, rather. So I'm going to have Fy2. Fy2 will be equal to what? What's the value there? 150, right? 150 sine 45. So that's Fy2 is equal to, let's consult our special language. Sine 45 is still root 3 over 2, root 2 over 2. So that will give us what? 150 times by root 2 over 2. So the value here is root 2, please. Root 2 over 2. Now, mathematics students will know that we're going to end up with Fy2 equal to 75 root 2 right there. So let me bookmark my answer. Let's divide this side by 2. Divide here, that will give us 75. So now, total vertical component. So my total vertical component, that is what, let's call it Fy, will be equal to what? Fy1 plus Fy2. And when we bring them all together, we're going to have that this should be equal to, the first force I have there is 100. So 100 plus, I have 100 plus by 75 root 2. So that is our what? Our vertical, our y component. Now, your resultant now, your resultant vector will be equal to summation of f of y, all the y components, plus summation of all the x components. And you've seen that already I've calculated all my y components and I've calculated all my x components. What I need to do is to plug in my values. So what's the total x component? 100 root 3 minus 150 root 2. So I have that total, I have already. Someone should call the value for me that I have on paper, so I will stop scrolling up and down. Horizontal, I have 100 root 3, 100 root 3, 100 root 3 minus, nobody's calling it for me. You guys don't like me, I know. 150 root 2 plus 100 summation of Fy. Sorry, I misplaced this. I want to put it in order so that people don't get confused. So f of y is 100 plus 75 root 2 plus the other one, which is our x component, is 100 root 3 minus 150 root 2. So when we bring them all together, are we there? So when we bring them all together, yeah, Meso, I can see your hands up. Can you go ahead and ask your question?
I thought F2 is 300 newtons, but you solved with 150 newton
Which one?
against
F2?
Y2, yes.
No, nobody said any other thing. The other persons we are just following that just that way. Sorry about this.
So confused.
Oh, sorry. And you didn't say anything all this why. You're all confused. Then one person is talking. This class, they're always looking for one person that will talk. And they'll be dying in silence. Though that's a mistake actually here. So this should be 150. I know somebody will now be saying in their mind, I talk calm. So 150 root 2. Thank you so much for that prompt. God bless you. All right, so 150 root 2, which will virtually affect what I have here. So what I should have here for Fy should be 150 root 2, right? So here should be 150 root 2. 150 root 2. So let's cross check again. Fy, so cos 30 was root 3 over 2, right? And then we'll simplify right here. I have sine 30, Fy components. So I had sine 30, that gave me 100. This one gave me 150 root 2. So let's collect like terms for the resultant vector. So that will now be equal to, this will now be equal to, are we there? 100, I'll bring up 150 root 2 minus 150 root 2 plus 100, right? Plus 100 root 3. So this side will cancel out. This will give us 0. Here will give us 0. So that our resultant, the resultant vector will be equal to 100 plus 100 root 3. You can punch and give us the actual value in decimal. The resultant vector. Anybody with calculator there can give us the actual value.
Two hundred and 73.2.
200 and what?
273.2.
Okay, thank you so much. 273.2. Others, do you agree? I want people that use scientific calculator. I don't need those that use the calculator they use in selling provision store. So 273.2 is very correct. So we have 273.2. So 273.2 Newton. So now this is the magnitude. Remember, this value you got here in bracket is the magnitude of the resultant vector, right? Now to get the direction of the resultant vector, are you there? To get the direction, I mean to say, so the direction now, how do we get the direction? It's as simple as anything. So direction will now be equal to summation of sorry, not summation again. Direction is going to be the tan inverse of y, or the y component, divided by your x component. That will give you the direction of the resultant vector. Is that okay? So the direction now will give us sorry, the way I wrote this thing is very bad. This will be this way. Tan inverse of y over x. Right. So let's put off our entire y value. Total vertical component is what? I think I didn't erase something here. This will be 100 plus 150, right? Yes, 100 plus 150. So as we have, this is y2, 100 plus 150 root 2. So let's get the value. So tan inverse of 100 plus 150 root 2 divided by x value. Total x value is 100 root 3. Pause this here. I think it might throw an error. Pause this. Let's see. 150 root 2. Meso, give us the tan inverse of this. But like I said, they always give you the one that you can use special angles and it simplifies out. Do you understand? Anyone punching? Susan Abraham, are you in class? Are we in class? What happened? Sorry, I didn't hear what we said. So who is talking? What's the value? That value does it exist? plus 150
I'm
root 2.
getting 30.
30, is that what you have?
Yes.
Okay, so let me punch as well. So 100 plus 150 root 2, tan inverse of that value, close bracket. Sorry, my bracket has refused to close. So I have 100 root 3 right there, minus of 150 root 2. Science students, is it only Meso that came with calculator to class? How are you getting one? How did you do it? I don't think I'm having the same value as you. But then let's simplify those variables so that it becomes easier for us. So let's do it. Break it down, please. So direction is equal to tan inverse, open bracket. Let's break it down. Let's break those values down. So 100 plus 150 root 2. 150 root 2. That will give us 312.132. Then I have 100 root 3 minus 150. 100 root 3 minus 150 root 2. That's giving me a minus sign. Is there any error with this? So F12 will give me this, right? F12 will give us this, F1, so minus 45. Okay, makes sense. Okay, this will give us this. Are we still together, guys? Everybody together? Are we all together, guys? Okay. Another person. So now, basically, because of the values, I'm trying to see how I can use my special angles. On the norms, I should just punch this in directly to get the answer. But because in JAM, you have to make use of special angles, right? And that's how I'm going through this stress this way. Yeah, but when we get JAM questions, we're able to apply all of this. But first of all, understand the horizontal component. Are we together? Yeah, so the first thing I did, as always, check out for your F1 cos theta, just that way. Simplify, get your total vertical components. Are we together? Good. So I have all of this. I think I should put the values down. That will make work easier for us. Magnitude. Sorry, I omitted something here. Sorry about this. Can you hear me? Now, what I omitted is that you should take the square root. So sorry about this. What was I thinking about, man? So square root of all these things square, and nobody's talking. All these things here squared. So sorry about this. My mind just went there now. All this squared. So sorry. Right? So we're going to plug in those values that we got. And I think the best thing we can do here, Meso, give me the values. Give me the actual values of this. 150 root 2. Give me the actual value, please. So I don't make this kind of mistakes again. Give me the actual values. 150 root 2 is what? 150 root 2. Give me the actual value.
150 root 2 is equals to 212.1.
Good. 12.1 Newton, right? Give me the let's work with the actual values. Let's go back to X values now. Let's go back to our X. Give me the actual values. 100 root 3 is what? 100 root 3.
3 is
Good.
1,732.2.
1,000 what?
732.2.
Isn't that too big?
Sorry, 173.2.
173 point what? 0.2, right?
Yes.
More the value shocked me. All right. So now we'll have F1. So do for me minus 150 root 2. What is the value?
I should do what?
Minus 150 root 2. Give me the value for that one too.
Minus 212.1.
212.1 Newton, right? Good. Yes. Thank you. So we'll have this value here. Others, are you following? Give me a thumbs up if you are following. I just want to, let's get the answer instead of leaving all those square root. Okay. Yeah. So now let's add our F components together. So F of X will be equal to what? May so add 173.2 plus not plus again, minus, because plus and minus is minus, 212.1. So what's the value you have? Total fx will be what?
Minus 38.9.
Minus 38.9. So we'll have minus 38.9 Newton as the total vertical horizontal component. Is that also? Minus 39 Newton. All right. So let's go again to our y components. So this one is okay. Good. So now let's add our y together. 100 plus 212.1.
100 plus
Yes.
212.1.
0.1.
312.1.
Okay, that will give us 312.1 Newton. So that's our total x value. Now, resultant vector says the square root of all the vertical components. Are you there? Square root of all the vertical components, all squared, plus all the horizontal components, all squared. So please punch the values. All this my square root I'm using here is making the whole thing much longer, right? But because I don't have calculator, that's why I'm always doing this way. Okay, let's go. What is your value for total x, y value? We'll have, this will be square roots. So we'll leave it to you now, punch. We'll have 312.1 all squared plus summation of x values. Others, are we following? Summation of x values is minus 31.9. So minus 38.9, I mean, all squared, right? So give us the actual value. You can take them one step at a time so you don't make any mistake. So the magnitude, so the resultant vector, all right, you can do it, you can break them down. Resultant vector should be equal to square roots. You can break them down if that will take much energy. 312.1 squared is what? Let's take it out that way.
Wait, 97,406.42.
No, for which one?
312.1 squared.
You said it's 37?
97,000.
Okay. 97,400 and what?
6.41.
0.41. Let's use 6. 0.41, right? Let's use 6. Plus 38.9 squared. It has negative into 20. Teacher, are you following?
Minus 38. I should add the minus sign.
No, if you take minus 38.9 times minus 3, it will turn to plus. So just do 38.9 squared.
The answer is 1,513.21.
1,000 what?
513.21.
Okay, let's appropriate now. So I can't hear the voice of Ferrami. Is he here? Is she on the call? So resultant vector. All right, guys, take the square root and give me the value.
Nice.
Square root and give me the value, please. Square root and give me the value.
309.
309.
Point
So is that the same thing you have?
6.
So is that the same thing you have? Another person should calculate will have two values, and let's be sure.
314.5.
So which one am I taking now?
My own.
Your own. Why should I take your own when you know you're giving me a value of this one? Meso, can you confirm your own again? Stella said 314.5.
That's what I'm trying to do.
Okay.
3.
At
314.5.
I said that's correct.
I added, you said we should leave that 0.41, but in my first value, I added the 0.41 for the first.
Okay, it's fine. Tiola, you've won now. Take your take your flowers. All right, so these are resultant vector. That's the magnitude. So now let's get the direction now. Direction is simply all the y values, summation of all the y values that you have, right? And summation of x values. So the total value, summation of y that we have is what? Y is 312.1. So 312.1, 312.1 divided by x values was minus 38.9. So you do the tan inverse of that and give us the value. So tan inverse of that value, what will it give us? So direction is what? What's the direction of the vector? Remember that direction is simply the angle theta of the resultant vector. So theta, give us the value. Give us the direction. Fast, 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 so we can solve more problems. Are we still working with the tan inverses then?
Minus the 82.9.
Another person, how can the angle minus something? Check well. They are fast too, guys. We spend so much time in this question. Okay, let me. You guys are pushing me. Let me use the calculator here. But can I remember the values? Shift. Tan inverse of 312 points. 312 point, what was that?
Point
312.1.
one. Yes.
Divided by what? Minus what?
Minus 38.9.
38.9. It's giving you the same value.
See?
Interesting. Okay. And that will give us minus 82. That also?
Yes.
Okay. So that will give us, there's no need of taking that value. So that will give us 82, right? That's the degrees right there. So that's how to estimate for the resultant vector. So get the horizontal component, all the horizontal component, take into account the quadrant where it is, find the vertical components, add them all together, take the square root. Then the direction of the vector is the inverse, just that way. Is that okay, guys? Any question? Everybody? Are we on the same page? Everybody on the same page? Everyone on the same page? Are we all on the same page? Let me call names. Emmanuel, Confidence. Emmanuel and Confidence. Emmanuel, Confidence, Titiola, right? And Meso. All right, so let's solve the next question right here. Okay. We are not touching us. What happened? That means you've not been listening. You can't take us back because it's not a big deal. Yeah, that's why the video is recorded. All right, so look at this one now. And this will be the last question I'm going to solve. And I'm going to be very fast at this point for this very one because I've explained the concept. So now, everyone pay attention to this very last question. So the resultant vector, I should find the resultant vector for this. Now, there are how many forces here? We have 1, 2, 3, 4, 5. 5 good forces. So now let's go for the horizontal component. Everyone pay attention now. So for the horizontal components here, we have the first value you can see in the horizontal is, let's use 8. So this one is already on the x-axis. This one is already slanted. So there's no need of you slanting it again. Do you understand what I'm saying? This one is already on the horizontal. 8 meters is already on the horizontal. So there's no need of what? Touching it or resolving it. So my fx1 is equal to what? 8 Newton. There is no need of touching it. It's already on the horizontal. You cannot resolve it. So do you understand what I mean by that? that is already on the horizontal. So there's no need of resolving it. Do you understand it? Give me a thumbs up if you do. Give me a thumbs up if you understand what I mean by we're not resolving the other side again. That is already on the horizontal. Anyone that understand? Giving me a thumbs down. Now remember that initially we had something like this. That force was inclined at an angle. Because it was inclined at an angle, we are trying to resolve it to the horizontal so that it becomes this way. The angle will now be pointing this way. That's what we mean by resolution. But for an angle that is already pointing, is already down, is not inclined at any angle, it's just straight up, 8 Newton. There's no end of you resolving it, because when you resolve it, you're going to have 0. The angle is already pointing towards is already on the horizontal. There's no end of resolving it. So the angle at that point in time is 0. Do you understand what I said? Does it make sense now? Now, this force here, look at this guy. I should have actually said that from the beginning. I don't know why I forgot. During my introduction, I should have mentioned that some forces will already be on are not inclined. So this guy now, this 20 is inclined at an angle. 20 Newton is inclined at an angle. So now tell me, what angle is 8 Newton inclined? What is the angle of inclination of 8 Newton? Titiola and others. What angle is 8 Newton inclined? Is 8 Newton inclined at any angle? 8 Newton, is he inclined at any angle? 0. Good. The angle there is 0. It's not inclined. So now, is 8 Newton inclined at an angle? No, it is not inclined at any angle. So you cannot bend it. Where are you bending it to? It's already on the horizontal. Remember that you only bend when the force is inclined at an angle. You want to bend it to this side so that it becomes straight, or bend to this side so it becomes horizontal. But that guy is already horizontal. He's already lying down on the horizontal axis. So there's no angle where you're going to bend it to. Titiola, do you understand now? Do we understand? Everybody, do we understand now? So the angle there is 0 degrees. You cannot actually resolve it. Example, another one now. Look at this one. Look at this one acting down like this. Let me ask you a question now. This force pointing downwards like this. This force, can you resolve this force to the x-axis? Can you resolve this very force to the horizontal? It's already pointing like this. Can you resolve it to the horizontal? Is it possible? No, because it has just a vertical component, which is just pointing down. There's no angle. It is when you have an angle, a particular force inclined at an angle, that you can resolve to the horizontal and to the vertical. Everybody, does it make sense? So what I'm trying to say is that this guy, 30 Newton, is already in the y component. So you're not resolving anything. 60 Newton already is straight up, is already in the y component. So we're not resolving to the y, we're not resolving to the x. This guy, 8 Newton, is already in the horizontal. We are not going to resolve it to the what? To the y-axis. Everybody, does it make sense now? If it makes sense for everybody, give me a thumbs up. Good, Chino, so thank you. Good, Mesoma. Confidence. Confidence. Titiola. Good. Susan. Susan. Susan, it be like say we go just join class, make it be say you dey for class. Eh? All right, so let's continue.
I'm in class, I'm in class.
You are in class. Do you understand what we are saying?
Not really.
Okay. They are speaking English for me, not really. Ngwan, Lillian. All right. Let's proceed. The next one now, the next value I'm going to resolve for the horizontal component is, let's look at 20. Now, 20 is pointing to somewhere. It means that fx2, the angle here is 60 degrees. And I want to bring this 20 so that it will lie down flat to the horizontal. So it's going to be what? 20 cos 60, because the angle is with the horizontal. And from our special angle, cos 60 is 1/2. So I'm going to have that fx2 is equal to 20 times by 1 over 2. So that Fx2 is equal to 10 Newton. I have my Fx1, I have my Fx2. So the next one now, I have resolved 20, I've resolved 8 Newton. The next one I'm going to resolve now is our 5 Newton, which is our Fx3. So Fx3 is equal to, but we'll have to account for the position where it is. You can see that, remember that here is positive y, here is negative y, here is positive x, here is negative x. Now you can see that that very force is in the negative x direction. So when I want to resolve it to the what? To the what? To the horizontal, and it's going to be minus 5 cos 30, because that angle is with the horizontal. So I'm going to have minus 5 cos 30. So minus 5 cos 30. Now Fx3 is equal to, minus 5 is what? Minus 5 cos 30. Cos 30 is root 3 over 2. So I'm going to have minus 5 times by root 3 over 2. So give us the value. Fx3 is equal to, let me find a way to point this. Minus 5, so we can save time. Minus 5 times root 3 over 2. Minus 5 times by root 3.
Minus 4.3.
I didn't hear you.
Minus 4.3.
Yola, okay. Minus 5.3. Is that what you said?
4.3.
4.3. Okay. Minus 4.3 Newton. All right. So that said, we'll cover up for Fx3. Now, let's look at the horizontal vertical component now. You will see that 60, there's no need to resolving 60 already. 60 is already pointing to the vertical. It's just a straight line. There's no angle. 3 is already in the vertical. We'll just have to account for the symbol plus here and minus here. So the next we're going to resolve here is 20. 8 is already standing in the x direction. So there's nothing to do with the y component. So the key, guys, is what? 20, 60, 3, and 5. So let's look at 20 now. 20 is going to be sine. So for the vertical component, let me quickly copy that so that we don't have to be scrolling up and down for that guy. All right, I think with this we are good to go. So let's do that of the vertical components. So the vertical component, but before the vertical component, let's get the total. So we'll have, let me draw a line at the center here. So summation of x of f of x will be equal to fx1 plus fx2 plus fx3. So that summation of fx will be equal to 8 plus 10 minus 4.3. So that summation of fx will be equal to what? We're going to do 8 plus 10 minus 4.3. So that will give us 13.7 Newton. So I have 13.7 Newton. So we'll have our value right away. So final answer is what? 37.7 Newton. All right, so for the vertical component now, we have that, let's call this one Fy1 to be equal to 20 Newton pointing up, which is positive. So let's have Fy2, which is pointing, I think it should be pointing downwards. That is this one. Let's bring it up a bit. Yeah, here is okay. So that value there is going to be 3 Newton. If you're observant, you are going to see that will have F3 Newton right there. So the value here is what? 3 Newton for Fy2. So having said that, we have 8 Newton, 20 Newton, 3 Newton. So let's resolve that of 20. So 20 is going to be sine. So FY3 is going to be 20 sine 60. So that FY3 is equal to sine 60 is what? Sine 60 for special angle is √3/2. But you're expected to know these things offhand, actually, for your exam. So this is 20 times by √3/2. So this will cancel, and that will give us 10 right there. So we have that this is 10 times √3. So that FY3 is equal to 10 √3. So FY3 is equal to 10 √3 is what?
17.32.
17.32. Thank you. 17.32 Newton. So we have two forces, as you can see there. We have Fy3, we have Fy2, we have Fy1. Then finally, what's the value that we have there? I've done for 20, I've done for 60. So let's do for 5 Newton. Remember that I made a mistake already and nobody saw it. What was that mistake? Here should be negative 3 Newton, because that one is pointing to the negative direction. It's in the second quad. So this will be minus 3 Newton. Everybody, do you agree that it's minus 3 Newton? Do we agree that here should be minus 3 and not just 3? Do we agree? Give me a thumbs up if you agree. All right, thank you. So now the next one, I have Fy3. So the next one I want to resolve is the 5 Newton, which happens to be in the negative direction. And is actually, the angle is actually with the horizontal. So I'm going to resolve that very guy to the horizontal. So 5 Newton, I'm resolving to the horizontal. So I should have Fy4 is equal to, what was the value that I have right there? The value there is 5 Newton. You're going to be negative 5. So negative 5, and the resultant vector there is going to be sine 30. So that Fy4, Tito Langba, I think you're faster now. So sine 30 is what? From our special angles, sine 30 is 1/2. So minus 5 times 1/2 should give us 2.5, right? Minus 2.5. So that Fy4 is equal to minus 2.5 Newton. Right. So we have every angle represented, all of them represented. So what I need to get now is the total of them. So someone that is fast can proceed to give us the total value. So summation of f of y will be equal to Fy1 plus Fy2 plus Fy3 plus Fy4. Summation of Fy is equal to Fy1 is 20. Are we together, guys? Is 20 minus 3 plus 17.3 minus 2.5. So that summation of Fy is equal to what? Someone give us the value, please.
31.82.
31.82. So 20 minus 3. Yeah. You said 31 point what? 82, right? So that gives us 31.82. Thank you for being proactive and for making the job easier. Yeah, if everybody's punching this, by now I should have been done with all of these things. But I will get the ball, I will dribble, I will defend, I will still score, and I will still go back to my goalpost and keep. So now the next one, we have the vertical component, we have the horizontal component. So now our resultant is going to be what? The square root of summation of f of y squared plus summation of f of x all squared. Now we have our f of y to be 31.82 according to Eniola, which is also good. That's 1.82. So that resultant vector is equal to the square root of 31.82 all squared plus summation of f of x. Summation of f of x is 31.7. So I have 31.7 all squared. So that the resultant vector will be equal to, we'll have square root of 31.28. Okay, let's take it one after the other. 31.82 squared. That will give us square root of 1012.51 plus 13.7 squared. That will give us 187.69. So the resultant vector will now be equal to the square root of 101.51 plus 187.69. So that will give us 17.005, which resultant vector is 17 Newton. So that's the magnitude of the resultant vector. So magnitude of R is equal to what? 17 Newton. Now, how do we get the angle? The direction now. The direction of the resultant vector. So direction of R in brackets theta is equal to tan inverse of what? F of y all over f of x. So that the direction will be equal to what? Tan inverse of what? F of y, total f of y value. Total f of y is 31.82. So we have 31.82 divided by total fx value. Fx is 13.7. So that will give us 13.7 right here. So that the angle theta will be equal to what? Shift sine inverse of 31.82 divided by 13.7. What am I seeing here? The 82. Tan inverse rather. Tan inverse of 31.82 divided by 13.7. So that will give us 66 degrees approximately. Does that make sense? So you've gotten your resultant vector and you've gotten your angle 66 degrees. Is that okay? So that means from to represent this thing, let's say they ask us to represent this, right? So in case we should have something like this, let's have this angle right here. Since here is 66 and the resultant vector is positive, R is 17. So it means that it should be on the first quadrant. So you should have something like this. And the angle, this is 17 Newton. And the angle around that very guy should be 66 degrees. So in case you are asked to represent. So that's exactly how to handle your resultant, resolving more than two vectors. If you have to resolve more than two vectors. But remember that the fact that this angle, all of them, tends to be to the vertical, to the horizontal, I mean to say all the angles are given to the horizontal. Know that sometimes you can have something like this. Instead of them giving you this 60 here, the angle will not be this side. They can give you the angle here to be 60 degrees. Then you have to start resolving using that method. But for me, I can still make use of cos and everything, because if that place is 60, that means that this side is 40. Do you understand what I'm trying to say? The angle can be twisted, as the case might be. It all depends on you and how you navigate for it. It all depends on you. Right. Are we all on the same page? Are we all on the same page? All right. Thank you. Mesom, are you there? Good. Who again is on the call? Ezra, are you there? Ezra, are you there? Good. Suzanne, I don't know what else to do. Suzanne, send me a message after now. All right. So this is what we have. Let's quickly recap all that we did. Right. So I introduced your your resultant vector, resolving vectors, getting the resultant. And I said that there are two cases. Case one is when the angle is with the horizontal. So it becomes horizontal components F1 cos theta, and the vertical component is F1 F sin theta. Then we'll have the case two, a case where the angle is with the vertical, and we'll end up with flipping the signs, right? But what I'm trying to say, for me, I don't need to remember which one is case one, which one is case two. If I have this angle here, if here, pay attention now. If I have, and if you give me the angle here, let's say that the angle that was given to me, let's say they gave me here to be 60 degrees. Pay attention. Let me just give that hint to people that will understand. Let's assume they gave me that angle with the vertical to be 60. I can get the angle here because this is 90 degrees. So 60 plus 30 is 90. It means that this place is 30 degrees. Here is 30 degrees. This side is 30 degrees. And therefore, I don't need to start finding I don't need this angle. I will continue with the same formula. If I want to maintain the same formula all throughout any question they give me, if that angle is with the vertical, I just use 90 minus vertical to get the angle here, and I'll keep maintaining the same formula throughout without changing case two or case one. If you understood what I just said, give me a thumbs up. If you got the insight I just shared with you now, give me a thumbs up. Anyone that got the insight I just shared? Women of Jerusalem. Okay, look at what I'm trying to say, guys. Look at what I'm saying. Now, I'm just trying to add something. Remember we said angle with the horizontal, angle with the vertical. It wouldn't be fine if I leave you guys without saying that. I wanted to leave without saying it. But then, let me just add that as a plus for those that will understand it. You have a line like this. You have a line like this. Now, you have this way. And now, the angle is given to you here, theta. Let's get theta 1. And that angle is with the horizontal. Remember that this is your F. You can complete this here. This is your F of Y. This is your F of X. Now, and we said that if the angle is with the horizontal, that we're going to do what? F cos theta for F of X, right? And then for F of Y, we're going to do F sine theta. Is that not what we said? That is when the angle is always, when the angle is with the what? With the horizontal. Give me a thumbs up if you are with me to this point. This is what we agreed on from the beginning of the class. Now, I'm trying to say something else now. And we said that if the angle is now with this side, if the angle is now with this side, let's say theta 1, that this thing will not change. That this side now will become sine theta. Here will become sine theta. And here will become cos theta. That's what we agreed, right? A thumbs up again if you agree. That's what we agreed. Good. But I'm saying something. I don't need to start cramming case 1, case 2, when the angle is with the vertical. I can always remember I want the angle to always be with the horizontal, no matter what they give me. That's just a plus, if you like. Just a plus. Now, if you give me the angle here, let's say the angle that was given to me here, the angle is with the vertical now, right? And the angle here, theta, is equal to 40 degrees, which means the case I'm going to use is the case when the angle is with the what? The vertical. But if you don't understand this thing, don't worry. Just maintain the case 1 and case 2. Now, I'm talking about those that don't like cramming like me. Right? So you have this angle here. This is the theta now. The angle is with the vertical, right? Which means the formula will change. But the whole of here now, the whole of this angle, all of this place now will give you 90 degrees. What do I mean? The angle here is theta 1. This side now is theta 2. Theta 1 plus theta 2 is equal to a 90 degrees. Do you get the point now? So if you give me that the angle is with the, if you give me that the angle with the horizontal, with the vertical is 40, I will just do 90 minus 40 and bring the angle back to be with the horizontal. Do you get the point now? So which means that if you are giving me that the angle here is 40, I can easily get the angle here now, the angle down here. I can get this angle here. The angle here is going to be what? It's going to be 50 degrees, and I will maintain my angle. So if I'm trying to get, if I want to resolve this force now, Remember what they gave me was angle 40. That was 40 that was given to me. But I want to resolve this guy to the horizontal. What I will now do is what? That fx will now be f cos 50. I will neglect. Look at what I'm saying. Point this answer, I'm going to get the same thing. I'm going to have that fx is equal to f cos 50. But in actual sense, the value they gave me was 40. And the formula I was supposed to use because of that should be f equal to f sine 50. This should give you the same answer. Someone should check that. Sorry, sine 40 here. Because 40 was what was given to us. This will give us the same answer. So someone check that. It will give us the same value.
Yes.
Good. It gives the same value. Tiola, have you seen it? Ezra, have you seen it? Confidence, have you seen what I'm saying? Good. So anyone you want to do, if you want to say, remember case 1, case 2. So for case 1, when the angle is with the horizontal, I use this formula. Case 2, when the angle is with the vertical, I use the formula. Or I just want to remember that the angle is what? The horizontal. Then if they give me the angle to be the vertical, I'll get the corresponding angle in the horizontal and I keep solving. All right, so that's what will bring the class to an end. And I sure do hope that you got value from this class. And I'm sending you out to the world to go and solve more past questions, just like Jesus Christ sent his disciples to make disciples of all nations. I'm sending you out now to go and solve as many questions as possible regarding vectors. It is expected that anywhere you see questions on vectors, that you should be able to answer them. And I sure do hope we are going to answer it. I'm wishing us all the best. Any question? Any question? I hope you are not confused, right? If you are all good, let me see that on the chat that we are good. If we are all good on the chat, let's agree. If we're all good with the class now, just type in, let me know you are good. And then I can go. Yeah, we are good. Thank you, Anne. So that means you can solve every question. Yeah, good. You can answer every question that has to do with vectors. And at every point in time that you can and that you will. All right, we are good. And I'm going to call Susan. I'm going to call you after this call. Just keep your phone close. We need to really talk. Let me know what the problem is. Let me know whether it is the clipper, right? Is it the clipper? Is it the barber? Is it the hair, or the person that the barber is trying to barb the hair? So there are 4 cases. So let's know where the problem is coming from. If it is the clipper, we'll buy new clipper. If I'm the problem, the barber, we'll change barber. If it is the hair, then we'll cut that hair off. Let's see what the problem is. All right, guys. All the best. Yeah. All right. One love, guys. Yeah. Bye. The recordings will be made available. Right. Yeah. Good. Bye. Yeah. Thank you.